Hello everyone, welcome to 16 Bits channel. I'm Luis and today I bring the topic about the numbers, how to avoid mistake using numbers. Okay, this is a topic regarding avoid choosing or picking some primitives instead of using the class. Okay, so I will bring this topic because this is an important topic to you modeling a system or fixing a bug or even to choose or to improve your system and also your knowledge. So the important thing here is what kind of number I need to pick on the Java, using Java, because you have, let's say, big integer, big decimal, long, float, double, integer I said, okay, short, long accumulator, long adder, and a lot of flavors of numbers. Some kinds are using to work with string and others to work in type of your modeling, let's say your domain. For instance, you use to choose integer to be a primary key. Sometimes you can choose a long. What a difference if I pick a big integer instead of long, or using a int instead of long? Maybe I have some problem in the future. This is a good question, because we handle in this case about capacity, and capacity, once you have stored or your system running, to change you need another deploy or change in some part of your system. So the main message for this video today, and I'll bring some examples, some cases also, and try to explain by code and by some presentation how to choose the best number to avoid problems, and the more important, reduce the errors. Okay, because sometimes it's inevitable make mistakes, but if you had some background or some idea about the system, is more, let's say, feasible choose the right type of number. Okay, that's it, and now let's to the code. Hello everyone, now it's time to code, and I bring this presentation to follow us in this code. Okay, I think about this topic. I thought it's better breaking down this topic in many topics. So right now I'm bringing just a few of primitives, and then we'll bring the class, and then log and long accumulator, yes, and so forth. Okay, so let's see the numbers, in this case about the primitives. The primitives, we have some kinds, as I said, byte, short, int, long, float, double, boolean, and char. So I can't store a value, let's say a number, inside a boolean, because boolean only stores false or true. So in this case we can avoid or forget some primitives, let's say boolean, and char also, because it's useless for this kind of moment, and work with short, int, long, and floating double. And more, let's say, how can I say that? But in my case, in my career, I'm just used to work using int, long, and for some calculation or special case using double. Float, not so much, and double, and also big integer and big decimal. But right now the big int and big decimal is not here, is in another part of this presentation and another video I will create as well. So now we have some details regarding the default values, regarding the max value and mean value. Basically the main idea behind the scenes working with the primitives has a static value. So a primitive don't have to create using the new, as you can see in your class, or using the array list or another kind of list. So you can just declare and associate some value. By default, we have here some default values, some kinds, in case byte, short, int, long, and so forth. So in this case, we have this kind of mean and value. This is the basic of the primitives. And what exactly the gain about the primitives? The gain is the size, in this case, the memory footprint. Okay, but you said for me, okay, I'm working with the system, we have the application server using gigas of memory and so on. But think about the cloud computing right now. Right now, everything or the mostly of the system are migrating or are cloud native. So you are using more resources, in this case memory, or using more disk or more kind of resource. You are increasing your final cost. This is the to keep in mind when you try to choose between the primitive and between class. I know sometimes using a class is better because you can use some methods, and primitives you don't have any method. Let's say you have the int receive value, let's say 42, and so on. It's over. You don't have you unable to manipulate this value. But this is it depends of each system. Okay. And then now let's see an example of the code using Java and IntelliJ. But firstly, let me back here. Maybe almost 2 years. Let's see here. I written an article in Medium, let's say, in June 24, a long time ago, maybe in few time, 2 years. I wrote this article regarding this data, explain some primitives and primary key, and well, it's a long time, 2 years back. Back in time is all I got which back in time. So now we can see here the class. The class is inherited from number in some case, implementations of number, So this also is good to have how many data or how long this kind of variable supports. In this case, you need to pay attention, and big decimal is how much you need until your RAM memory supports. Okay, so until you have memory, you can work. In some cases, if you're using an integer or a short is too short, is extremely dangerous for a system that have increasing perspective or widely used over the company or over the world. So I will put this link also in the video description. And I have some conclusion here, and I have some links to Oracle, and I use it also this documentation about the primitives to explain and write my unit test. Also, this another oh sorry Command Z. I have this another link. It's very very good to see, because in this link they have the more options. Obviously, agree. The footprint, when you have the primitive, let's say boolean, instead of using the class boolean, is a huge difference. So pay attention and use the primitive when applies, and use the class when is applied as well. So let's go to the code. Let's close the keynote. This is not long required, and Safari as well. Let's go to the code. Okay, now I create, let's change the preference. I want to change my preference. Yes, my preference, I put this 17 is good. 70 is good. And right now this is the JUnit5. If you never touch, is I using here the nested class, because I can written here, I'm working with primitive, so I can written a class, let's say long tests, and starting to type my class. Okay, so void should store a integer value. Okay, so this is assert that. I use an assert that here because I'm implementing the assertions. Okay, so this is important to know, because with assertions is more clear to read. Okay, in this case I want to this is expected. Yes, actual, and as the key type description should store integer max value in this case is equals to integer max value. Okay, so now let's create this actual, create a variable. This should be a long, receive the integer point to max value. Okay, is equal to, maybe I type right wrong, is equal to, not equals. Equals is the method of the Java. Okay, so let's I have one broken, no, not okay. Let's just to run this test and see what happened, because I'm comparing the max value of the integer using the long. Nowadays is very common to start off using the integer as id, using the primary key. Sometimes using long is a not good approach, because if you have the system receiving or creating a lot of data, this id will be extremely used. So the important thing is, maybe it's time to change to big integer, but the big integer and big decimal I will bring on the next video. So in this case I want to store an integer. It's perfectly correct, because the long is bigger than integer, so you can store an integer value inside a long value. Okay, so I written more tests here regarding the these values. I know this is a little bit weird, but if you have some problem to understand, you can do it, okay? Let's say to hexadecimal, you can say 2021, what is the value of 2021 in hexadecimal, okay? And then you can, let's say, on variable, and put this variable, the content of this variable up here. Let's do one thing just to know about it. This is the magic number. Maybe it's a magic number. This number represents hexadecimal, it's 42, and this number here represents in binary the number 42. This is parameterized test. This is okay, it's no problem about that. This is another test. I want to get the max value of the long and put this in a primitive. I need to cast this value, and at the end I have non-value because the max value here is bigger than supported by this primitive int. Also, we have the autoboxing and unboxing. In this case, I want to associate a primitive to a class, and the vice versa in this case, okay? I want to store the value of the class integer inside a primitive. This value also is equal. The big difference here, as I said before, using the class, if I want, I have the methods to manipulate or do more things than I need, okay? But the essential here is just to show some methods, how the primitive works, and if you know the concept about the one kind of primitive, let's say about the integer, you can apply it to float, to double, to short, and so on. Right here, I create another. Well, this is a weird test because I want to execute 100,000 times in this while loop, and the first case I'm using the dummy variable. I want also, if you want to, I can do that. Well, I want to change this test, okay, just to know. And also I get in this, let's say, the elapsed time of this loop, and after using integer class, also I do the same thing, and at the end I want to see what happened. The difference, let's say, the primitive should be less than using the unboxing, and this is the test just to show. But in real time, in real life, if you're working with boxing, autoboxing, unboxing, autoboxing, unbox, try to avoid this kind of situation, because this will increase your memory footprint, increase your processing time. Remember, using primitives, you don't have the computation, you don't have to the same steps of the class, just to keep in mind. And then another test just to check if primitive supports the max and the min value about the class. This is the main idea, okay? This is the main idea. As I said, I will put this presentation, the links of this kind of the class kind of material inside the video, on the video description. And up to you. On the next video, I will bring more detail about this, how to work with the class, let's say the number, the childs of the number class. Well, files, yes, okay, I have the files, Java, util, just as well, don't matter. I can do another way. Command B, and go to the number. Yes, this is the, and see here all the classes. Okay, so in the next video I will bring to you this all the class and talk about a little bit each class and how this class work together. But keep in mind, if you know how to atomic long works, the atomic integer should be same unless the size support the size, and the big integer to the big decimal is the same, so you can split this class by 2. You can divide by 2 and you have the result. Okay, so for now this is the video just to bring overview about the primitives, and then to the next video to know about the other classes. And keep in mind, the more important thing is thinking ahead, and don't oversize the things. If your system don't need a big integer as ID, don't put a big integer, put integer or a long, just you need to have the measure of the system before to build. This is a good device. Okay, so thank you very much for your attention and see you on the next video. Bye bye.